Hey, folks. Hi, welcome to another Quarkus Insights show. Our usual appointment here on Mondays afternoon for most of you folks. Today we have a super interesting session with some excellent guests that I'll introduce very, very shortly. Our session is entitled Quarkus Helping Optimize Covid-19 Testing. As you guess from the title, this is very interesting, not only because it's applied Quarkus, but because we're going to hear from folks that actually help all of us in this current pandemic situation. So now to get to our guest today, we have Dimitris, who a lot of you folks will know from the Red Hat JBoss days. He'll give us a few words about who he is. Before, let me go to our other two guests. We have Ioannis and Vangelis, who are from SciTech, and they are the folks that are actually using Quarkus in production to help us with COVID-19. So, Dimitris, want to say a few words for those few folks who might not know who you are?
Well, many years with the application server team. And lately, I'm running essentially the Quarkus team as an engineering manager. And I have also in my group some other projects related to cloud native technologies like Vertex, Node, Spring Boot, Thorntail. So let's
all the good stuff.
Let's go to our guest, basically. Yeah.
All right. So, Ioannis, Vangelis, you guys want to introduce yourselves?
Vangelis, would you go first?
Yeah, sure. No problem. My name is Vangelis Antoniadis. I'm the CEO of SciTech. Actually, SciTech is a technology provider, it's a software company mainly focused on telecoms. But now we will talk about another kind of software that we develop and has to do with the public sector in general. As we are in a very, very difficult times with COVID, you understand that software and technology in general plays a very crucial role in this, in finding solutions or make things better. So yeah, we are involved in many different COVID-related projects, and one of them we will discuss it tonight. So, Ioannis, are you with us? I see you going in and out.
Yeah, hopefully I'm with you. I'm the team leader, the software team leader and architect in SciTech. I'm getting my hands on everything related to software, especially when it's something super interesting as yeah.
All right.
George, are you speaking? Because I can't hear you.
Sorry, yeah, I was on mute. Sorry. Just for a quick note for those who might have not caught the quick introduction, Vangelis and Ioannis are both working from Greece, right? So all the solutions we're talking about are applicable to Greece for now, but like maybe more general in the future.
Yeah.
Exactly, yeah.
So I think maybe you should say a few things about, overall what this system is about. I have to say that I was a user of what you developed. I've used it twice when I had to fly back to Greece, and it worked smoothly. So maybe you could say a few things. What is this really about? What you had to develop?
Yep. As you understand, traveling during the COVID era is not as simple as it used to be. So many countries tried to open their borders or leave their borders open, or or somehow permit tourists and travelers coming in the country, but in a way that they will keep the country safe from spreading the COVID disease. So one way to do that is to at least to use what we say as PLF, or Passengers Locator Form. And this is actually a form that you fill before entering the country, so the country organizations know where to find you, know where you're flying from, and in general know some things about you, and potentially take some measures. Each country do different things. For example, there are countries, or there were countries that they don't permit people coming in the country if they coming from another country, a specific country, or there are other countries that impose people to COVID testing before entering if they are coming from a country or going somewhere else. And one other very important thing about PLF is that country agencies need to know where they can find you, because they want to know how to limit the spreading of the disease. So at the point someone gets sick, or at the point someone is tested positive, they can find you and limit the spread. So PLF is something very important. It is a tool. It's not a new tool. You have to know that it is a tool used in other situations as well in the past, but it is a dormant, let's say, tool. And now that we are during a pandemic, as we understand, it is very important tool. The different thing from other periods is that now we need to use it in a digital way, because PLF used to be a printed form that you fill before entering the country, in some cases, in some countries. But it's not very efficient to use paper, as you all understand. And this is what we started to develop, what we developed during the summer in Greece. And this is how we managed, at least in Greece, to open the borders for tourists for some time, and at least permitting some tourists to enter the country. Mm-hmm. But it is the first aspect is the form, but the main and the most crucial part is how you use the data you gather from the form. So our job was to gather all the data and transfer this data or part of the data to other agencies like public health agencies or civil protection agencies, etc. And how you run a whole system based on the passengers' data and limiting the spreading of the disease. This is the goal here.
Mm-hmm. Yeah, I can also give the user's view, which is a bit more simple than that. Which you have to travel. You get the link. You go to a site. You provide your info. Who am I, and where do I start, or which countries I go through. And the day of the travel, you get back a QR code that essentially carries your risk profile, right? You do analysis in the background to specify whether it makes statistical sense to test a person upon arrival. And then when you arrive, well, you try to guess from the QR code if you are the chosen one. There's a mystery behind this. And then, you might be tested. The next day, you will know whether you have to quarantine or not, or you are free to continue your holidays or whatever it is that you do, right?
Yes, exactly. In Greece, the outcome of the PLF, what you say, the QR code, leads to be tested or not. This was the case in Greece, because now it's different. But this was the case during summer for Greece. Yes.
And just to give like a even broader perspective of why this is so important, was so important during the summer for Greece. Greece has like over 20 million tourists usually round year round, right? Well, basically in the summer, but which just means that Greece is its economy is heavily dependent on tourism during the summer. So it wasn't really an option for the country to like shut down the borders and say like we're not taking any tourists, right?
Yeah, exactly.
As well as the fact that fortunately or unfortunately, there wasn't the option of testing everyone getting into the country. So the second best option would be to identify the most risky, if that's an expression to say, people that would enter the country and test those, trying to find them. And the idea was that instead of doing that randomly, a machine learning algorithm, the guys that developed it, named it Eva, would probably identify the most risky people to test.
Yeah. Could someone say a few things first for this backend system you mentioned called Eva? I saw a video related to this. It's a system written in mostly R, essentially, and in Python, I think. And it uses machine learning to examine something like, they said something like 100,000 data points per day coming from all sorts of different inputs to derive the probability of, carrying the virus, someone coming into the country, so you can target your resources. So how you got to know those guys?
The guys are mainly it's about Kimon Drakopoulos and John Vlahogiannis, and there are their partners as well as some other guys behind this algorithm. And actually, they were the people coming up with the idea of installing and developing a machine learning algorithm to identify the most risky people to test and who to test or not. And we came up as a cooperation with them, building as we say, the broker platform, meaning there's the algorithm that gets fed with data about anonymized data of people entering the country, as well as who was tested and who got positive test result, and communicating this data with both the passengers and the government parties that need to treat with those data. This algorithm is developed, as you already mentioned, in Python mainly, but Python is used mainly for the data input and output. I mean, exposing the APIs to communicate with the broker, to receive the data and send back the results come up from the main algorithm that runs in R. And it's the one responsible of consuming all the data points and hogging up huge amounts of memory and coming up with the results of who is the risky one and who should be tested. The integration, it's not the Eva is integrated with our platform using APIs. They're communicating over HTTP about sending data and receiving back the results. It's all on Amazon, on the web services. So the VPCs in Amazon terms are interconnected, and they have a secure channel between them, and data is going back and forth.
Mm-hmm. But you do the hard work of collecting all the user inputs and the outputs, and then integrating the different systems that you have to provide data. And I understood that was a very, it's a liquid process, because it was changing all the time, new rules, new things, new places to integrate. And of course it had to work, because people, they want to travel. And So this is the Java part, right? So this brings us to Quarkus, and from your point of view, why you chose to go with Quarkus in the first place? Vagelis or Yannis?
I think it's Ioannis' choice to go that way, and we trusted him. And yeah, I think it was a wise thing to do. And I think, yeah, Ioannis, what do you think? Why we chose Quarkus for implementing this project?
You're muted.
You're probably muted.
All right.
Or my internet is not going to help us today.
Yeah, go ahead.
Yeah, we can hear you. Yeah. It seems like, yeah, Ioannis is having network issues.
Okay, so we had previous experience with Quarkus for some smaller scale projects and other stuff, which was quite positive based on the how it enabled us to test the application, to actually test the application, as well as how much it provided with fast ability.
Ioannis, if I might have a suggestion here, maybe you want to turn off your video feed because your audio is really chipping up here. Maybe if you turn off your video, things will be a little better. It seems like he dropped off.
He decided to, but I would like to add something here, and I think
yes, of
Ioannis
course.
would say something similar. From my point of view, and from our previous experience from Quarkus, what we really wanted at that point, I mean, when we start talking and discussing about developing such a project, and I'm in somewhere at the end of June. It was that we needed to develop it in very few days, actually. The first version should be up in, I don't know, less than a week. And this means that we needed a tool, a framework, to help us develop something robust and production level in a very limited time. And from our experience at that point was that Quarkus is such a framework, such a tool, such a I don't know, such a technology to say it correctly. And this is the one thing. The other thing was what Ioannis tried to explain earlier, that we needed to have a very good testing framework, because we are talking about a production-ready system, and we knew that we will have millions of PLFs, and if someone didn't get their PLF, they couldn't enter the country. So the impact is really, really huge. Even if 1 or 2 or 10 people per day couldn't enter the country, it is at least very uncomfortable for them, and at some point for us as well. So, Ioannis, you are back. If you want to add something.
I'm not quite sure if I'm back. I mean, the internet today is not going to do me any favors.
You are for now, so.
Say it now.
Yeah. While I still have internet. Yeah, there was simply no room for errors. No something not working exactly as it should. While at the same time having to be developed at extreme deadlines, meaning we had very few days to design everything and set it up and running, and very few days to incorporate any changes that were changing. Everything was changing at a huge pace. So Quarkus was the option that would enable us to both be able to develop the broker platform fast, but as well as test it and make sure that every change will be behaving exactly as it should, and no people will be rejected entry into the country or be deported even due to our issues.
I have a question here. So, did your company have like prior Quarkus experience, or was this like the first time you
As I
decided?
said, we already had a few examples that we used Quarkus, and we already had some insights into how it would speed up development, as well as provide very good feedback and fast feedback about tests, meaning how easy it is to set up an integration test with Quarkus, use up some resources like databases using test containers, and everything is up and running with just a few annotations, and then you're up testing your code very, very fast. These projects were small scale, but we already had the insight that this would be
Would it make sense talking a bit more about like testing and give us an example maybe how this was helpful for you? I think you have something to share.
Internet permits.
Internet problems, yeah. Maybe it's better with the screen sharing though.
Yeah.
Yeah, Johannes, if you want to like turn off your camera and share the screen, that'd be great. I mean, if you're still with us.
All right. Yeah. I think he will be back in a minute or so.
Yeah. Right.
Yeah.
So
let's play some music.
If folks want to ask questions, then obviously feel free to ask, because I mean this topic is hugely important and really interesting, because I'm sure there's a lot of insights that Vangelis can answer for us.
Yeah, maybe I can share some of our experience,
data?
not from or data maybe. Yeah, let's talk about figures. We run the system. We still run the system. So the system is still up and running, because if anyone want to enter the country, needs to fill a PLF, and will be there for some time. So during summer, and let's say about during August, we had more than or about 100,000 PLFs per day. That was a peak. And we now reach about 5 million PLFs in total. But this means that not everyone that fills a PLF enter the country. So we had many issues about how we will limit the faulty or the non-show PLFs. So maybe it's out of scope, but one very important aspect of the project was the infrastructure of the project, because we are talking about a production-ready system that it needs to be accessible from literally everywhere, because people from the US or Australia or Europe or whatever want to come to Greece for the summer, and need to be up and running all the time, and capable of servicing, I don't know, many requests. We have the figures there, but also to be secure, because we had a problem with denial of service attacks or non-password attacks or SQL injections, etc., etc. So,
were there actually incidents like this? I'm curious.
Yeah, sure. Yeah, because when you have a service that has very big impact to the country itself, to the reputation of the country as well, then there's always someone who wants to at least play with it, or at least do some damage because they think they can. So it was a problem. It was not a problem. It was a challenge, to be exact. And the good thing is that we persuade everyone from the government and the ministry that this is very important, and we need to invest actually on security and on availability, etc., etc.
Yeah.
So yeah, one thing was the code itself and Quarkus, of course, but another very important thing was the infrastructure and security and availability and things like that.
Can you say a few things about the type of hardware you used?
Okay, the whole thing is installed, is running from Amazon Web Services. So we either use on the EC2, I mean the virtual machines. We use some, not many machines. We use from 2 to 8 TAF3 large. It is okay. It's a medium-sized virtual machines. And most of the times we don't need so much power, and I think one of the reasons for that is Quarkus, the code we wrote, because the most expensive part, CPU related, is the PDF creation, because as we said before, we create PDF documents, which are the PLFs, and send them to the tourists or the passengers enter the country. So the most expensive part is this, and the reason is that we do that in batch. Every night at 12 o'clock sharp, we start creating PLFs in PDF and send them by email. And in some cases, we needed more than 4 such machines. But the most crucial part there is that we have the auto-scaling mechanism that Amazon provides. So if we need more CPU, more machines were launched. And we also have the load balancing that they provide and things like that. So it is not really CPU-intensive system apart from the PDF creation. And we did very good job in optimizing the PDF creation thing, because as you understand, it is not so fast, at least to create, I don't know, 50,000 or 60,000 PDFs in just 2-3 minutes.
Nice.
George, there were some questions.
There are a couple questions. So yeah, let's bring them up now. First question from Stelios is, Greece changed border admission policies several times. How did you cope with that, and how did Quarkus help in doing that?
Yeah, this is related to what Dimitris was saying earlier, that we needed to be adaptable to new changes all the time. And this is something that this project still has it, and because policies during COVID changes every time. And the answer is that yes, we did it. We did it based on 2 different things. One thing is that hard work, and the other thing is Quarkus, and mainly the testing. Because if you are sure that you won't ruin your code by changing just 2-3 lines or by adding a block of code, then you are assured and you can go production really fast. And this is where Quarkus really helped. And I think that it was one of the things that we discussed earlier, that it was very crucial for us, and we did the right choice at that point.
Mm-hmm. I think Christos wants to talk about testing, even without video. Maybe we can hear you, Christos.
Yannis?
Christos.
Yeah.
Yannis.
Sorry, guys. Everything's going wrong with the internet today. So, yeah, let's see if I can get up with some very few things about showing about testing. Hoping you.
Mm-hmm.
I filled the gap during your absence by saying, give it, and things like that.
So testing was like super important in this case. Like, I guess the fact that you were able to run all your like full test suite so often was really critical to this, like, let's say, agile specifications that were coming from the government.
Yeah. To be honest, if we didn't have the test coverage we had and the speed we had by running the testing, we couldn't sleep at night.
Wow.
Mm-hmm.
Yeah, the impact of an error is huge.
Yes, I see. I guess we're still having problems, to be honest, so let's go to next questions, I guess. We have a question here from Tokyo, who says, how did you reach a conclusion on expected service hits that the PLF application would need to support? So I'm assuming that Tokyo is asking, like, if you did some kind of capacity planning here or like a load testing before to estimate what you would need.
The thing is that when we started the project, we didn't know. Actually, we couldn't be, we didn't have any figures because no one knew if people would come to Greece or not. Okay. At some point, someone said that, guys, you need to develop a system that will support more than 300,000 tourists per day.
Mm-hmm.
We said, okay, he's someone from the government. He knows what he says, but the truth is he didn't, because he couldn't know during COVID what will be the expected tourist traffic. So what we did is we said, okay, we don't know, so let's make this. What?
Yep.
Now that I can, what we can see here is, through Jenkins, the tests. What we can see is,
let's jump straight to the CI then.
Yeah, we're testing everything at around 1 minute. So our tests take up nearly 1 minute only. And it's not because we don't have tests. It's because we're able to run them super fast using Quarkus and Quarkus test resources. So if I can also share some of the tests that I've prepared to show, trying to show only what's important and available, hiding everything related to the things that should not be shown, at least at this time. We have what we say the E2E test, meaning these are tests that test each PLF for the full life cycle, meaning from the time that a user, a passenger, submits them up to completing the life cycle for the passenger being tested and then getting back the test result back to Eva that should be notified of this data so that the predictions get improved over time. So what we're doing is we have the Z2E method that we're going to see, and we're using it for testing every kind of different passenger locator form a passenger would submit, as well as some other cases about errors and requirements for negative PCR for each passenger, etc. So if we head back to see what's happening here, we can see that we get a PLF, passenger locator form that we need to submit. So what we do is submit it via API for each user, and we can validate that we have a hash for the form, the page that gets rendered, but we don't have a QR code yet because Eva has not sent back any feedback yet. So then we get on to verifying that we can see it via the API, the page that the users go to see to render the PLF, but there's no QR code yet, as we said. We also verify the emails. We're not using the standard mailer that comes out of the box with Quarkus because we've noticed that using it and the SMTP protocol, which was much slower than using directly the simple email service API of Amazon, which Quarkus came up with an extension ready to use it. So that's what we're using, and we're setting up a stub server for the tests to send the SES requests for the emails, and we get back the emails through the mailbox. So we're verifying that the confirmation email, the first email that the user, that passenger gets when they submit the PLF, is what should be expected. And then we resume each processor that is going to use the pipeline for getting the PLF to the next step. So we resume the processor that will forward the summary of this PLF to EVA. So we verify that the request is what it should be, the screening summary that is sent. And then we clear up the mailbox because we're going now to test about the PDF email. So what we're doing is simulate a result from EVA back to our broker platform, containing the result for a PLF about if it should be tested or not. And we unpause the processor that is going to handle these results from EVA. And then we verify that we received a PDF email containing the user's PDF and the user's QR code, and everything is as it should be. Finally, because this is not the only part happening, as far as the passenger is concerned, this sends up the trip for the passenger, but we have the integrations with the government and third parties, with the National Public Health Organization and National Covid19 Registry. So we also verify that we submitted the data for this PLF to the National Public Health Organization and to the COVID-19 registry. And then we verify that we received back the test results from the COVID-19 registry, meaning after the passenger gets into the country and they get tested and the test result comes up from the laboratories. This is then fed back so as to be forwarded back to EVA and inform EVA about whether the prediction was right or not. This concludes the end-to-end tests. And these, as we can see here, there are many such tests here, but the thing is that they're not the only tests that run, and all this takes up less than a minute to complete. Well, not less than a minute, but close to a minute.
So this gives you confidence for making changes. I was wondering, when you integrate so many different systems, things go wrong or they go down. So how do you deal with this?
this is mostly the part, some of the parts that they didn't show. It's about the processor and the queuing mechanism. So everything goes to the queue. What we're using right now for the queue is a database queue, taking advantage of the AWS Aurora database that runs on the background. Each processor, what it does is it uses batches because the amount of data is a lot, so we couldn't be communicating that about each one passenger located form. And what it does is that it handles data in batches from the queue. It takes up a batch, does what it should through the pipeline, and if everything is a success, it removes it from the queue. If it fails, it's simply left back in the queue with an updated time of when to rehandle it and when to move up the next attempt to forward the data.
Mm-hmm.
So
were there
how we're making sure that no data is lost, because losing data would mean losing this person not being able to enter the country. So yeah.
On the Quarkus side, were there any challenges or things you've missed?
Yeah, sure. On the Quarkus side, we had a lot of things to praise for Quarkus, but there were some pain points. One was about some bugs that hopefully will be fixed in the next version, as it seems. But apart from that,
hey, I already fixed your bug.
yeah, thanks a lot. There were a few things. As you can understand, there were many changes coming up all the time. And while Quarkus is using the microprofile config APIs, which contain some parts of dynamic configuration, this is a little bit limited because Quarkus wants to know everything at build time, or not everything, but as much as possible during build time. For us, this was not always possible. Changes were always coming, and we needed to be able to make changes on the fly. As everything is running, change something. And this was something that it was possible, but it was not very easy or intuitive to do as we would need. And the other thing is something that Yorgos might know better about the current situation and how to better solve it. But what we needed at that time was a way for having many threads handle some tasks. So we would need to have either periodic tasks or ever-going tasks of handling queues, monitoring queues, getting items, handling them in batches, because as I said, there was no point to handle each data, each PLF on its own. It should be handling that in batches. And there was an option. What I did, there's a feature request for that. But Yorgos might say that there's a even better way now to do it. What we did is have a simple Java executor start on many threads, and each thread, before starting its work, it would use the request scope context from Arc. It would enable the request scope context, and everything would start getting injected as a request scope for each thread to do the job.
Mm-hmm. Yeah, so I think now we have a batch extension like the JBaret or whatever the specification is called. There's an extension for that in the Quarkiverse. So the Quarkiverse is like an extended Quarkus platform where we have a lot of extensions that we don't want to be in Quarkus core because like we don't feel they're like absolutely core functionality of Quarkus. So I think that would probably be something that you should look at to see if that API can do what you want. Otherwise, yeah, what you did, like going the manual route with the executor, is like, yeah, that's the typical Java way of doing something.
Should we take any questions or
Yeah, sure. You already answered one of them, basically, with what were the limits of Quarkus. So that was just what Johannes was talking about. But there's another
If I'm
one.
lucky enough, I may be able to show you just one thing I wanted to.
Sure.
Okay, so yeah, I've created a few of the widgets we use for dashboards for monitoring what's happening. Here we can see the emails. This is aggregated, if I remember correctly, for 5 or 15 minutes, so we can see, yeah, the situation with the emails and how many emails they were sent. The fact that there were many emails at a single time point is because Eva creates the results during midnight for the and generated the results of who gets to be tested or not during midnight, and then we will receive a huge batch from Eva of who is going to be tested, and everything should be handled as fast as possible and get sent out the PDF and the QR codes to the passengers entering the country. And this is about the API requests that we receive per 5 minutes. And as you can see, it's not like the application is not having any job to do, but meanwhile, we can see the CPU utilization, which hardly ever gets back up to the 20% of the utilization. And this is about the network input and output. It just shows that there are many bytes coming in. It's megabytes, as we can see, during 5 minutes of what we receive and what we send out. But that doesn't mean that Quarkus can't cope with it, or it's using any more resources than it should.
And as Vangelis mentioned earlier, that you didn't need to use large machines on Amazon to do this, right? These like fairly small
hopefully,
instances.
It's all running on. Usually, it's all running on a on 2 C5 large machines. Everything, there's no thing like trying to see what doesn't work or not. I mean, it sits comfortably in there. Of course, it can increase horizontally, and for scalability reasons, it has a linear scalability horizontally for both sending emails and handling traffic.
And so you're using JVM mode, right? Not Quarkus native mode with QVM?
Yeah, exactly. We were comfortable with the JVM mode. We did not have too much time to get into the native stuff, so everything was working as it should in JVM mode, and no resources were lost. I mean, there were no huge machines needed, so we were happy to stay.
Nice.
Can I ask something now? I think this looks like generally useful, and I assume the more data you have, the better the system is. So, what are your plans for the future?
Also, there's a question regarding what Dimitris just said. It's pretty much the same thing. If there's interest from other countries on like integrating this within like the European Union.
Yeah, there is interest. As I said before, there are already some countries that they have implemented their own version of PLF. As far as I know, no country actually used a machine learning algorithm to choose who will be tested. But there are versions of PLF in different countries, not in many of the European ones. Now the European Union tries to find a way to somehow come up with a common policy about traveling, at least inside the European Union and from abroad. So now we are discussing about project combining all the knowledge and experience we gathered from the Greek PLF. I think that at some point in the near future, the European Union will have a common system, or at least a common set of rules about traveling with every mean to and from the European countries. So yeah, the one thing is that and we will be there. I mean, we are in this game for from this summer, and we will be, because we have great experience now, and we gathered it the hard way, to be honest. And the other thing that I think the European Union, and not only the European Union, but other countries as well, need to discuss and find a way to better tracking COVID cases, not only from testing, but also from what kind of close contacts these cases have, etc., etc. So in Greece, we have a system. We have also participated in developing such a system with Quarkus as well for the tracking of active cases, and we help Civil Protection Agency here. But I think that now we move forward to a solution that not we as a company, but as a society, that we need to share experience and develop a set of rules or a reference implementation or a common system, I don't know what. So we exchange this experience with other countries as well.
I saw a question popping up. So do you spin up more instances as the load increases, or it's like two big, apps running?
Yeah, there's a question as far as I can see about whether it's about running on two instances. It's quite complex, the infrastructure on Amazon, but it can be the main part, the main idea and the main parts in it are that there's an auto-scaling group with the application, which can be configured to automatically add instances based on the CPU utilization, memory utilization, or remove instance scaling when there's no point in keeping up too many instances. But it all ends up that two instances are running throughout the day, and during the night, during midnight, when the result from EVA would come back, it would scale out back to 4 instances, and then after 10 to 15 minutes for the most busy days, it could scale back into 2 instances and keep up with that.
Then there's more questions from Tokyo.
Yeah.
How do you generate 50 to 60K PDFs in 5 minutes? And he also asked what PDF library you use to generate them.
We will need my colleague Themis Zaganalis. I hope he's watching right now. He should be here to be answering such questions because he was the mastermind behind these numbers. But this was one of the huge pain points, the PDFs, and how to generate them in 5 minutes or 10 or 15. And the main idea is that you can't take more time to create the PDFs and send the emails, because you need to send the email to the passenger entering the country. If someone is entering after midday, everything's okay if it gets late. But if someone is entering at 1 o'clock in the night, 1 hour just after EVA gets the results, there's no way they can't get the QR code, because they will be waiting in a queue and say, yeah, but the system has not sent any QR codes, and so everything has to be super fast.
Do you remember the name of the library?
It's PyText PDF, if I'm not mistaken.
Yeah, but I remember that we did great optimizations there, and we tried very different ways. From straightforward converting HTML to PDF, or then using other techniques like PDF forms, you know what it is, and things like that. So yeah, it was a big challenge to do it fast. But yeah, Tokyo, if you're still listening, you can send us an email and Themis will respond with details.
Excellent. And Tokyo has another one.
Yeah.
Asking whether the PLF application can be extended to track a person while they're traveling within Greece.
The short answer is no. I mean, everything can be extended, but the PLF cannot track people because the PLF is a web app that you use only to fill some data while you entering or before entering the country. So when you enter the country, the only thing that we know from the PLF is your temporary, as we say, address. I mean, where you will stay in Greece for your vacation or your business trip. So then, if you decide to not go there and stay somewhere else, we will not learn anything about
Well,
that.
they provide the mobile phone. We could track the phone, no?
I don't
I
know.
was working in telecoms before, so.
Yeah, I know. The telecoms can track their mobile phone. We cannot.
The main idea of the PLF is for the civil protection to be able to communicate with the passenger if they test positive for the next few days after they perform the test. After that, yes. Right now, there's no shots.
So I guess the deeper question is if there are any like thoughts or you've heard like of having integrated this system with maybe like other systems that do support like such sort of tracking, have like a holistic kind of a COVID tracking system.
Yeah, there are thoughts, and as you understand, we are really involved in that, and we are working on a holistic approach, but not for spying people. What we have in mind is that we need a system as a country and or as a society in general that will involve everything. A system that will involve not only PLF, not only traveling from abroad, but also traveling inside the country, entering, I don't know, a stadium or shop, having your tests or your test results with you, and at some point having results from the vaccines, or you have you got a vaccine or not. So you know that COVID is here and COVID will stay, as everyone says. And this is, from my point of view, it is true. So we need systems to do that.
You know, tracking is a very big thing. Here in Switzerland, you know, you go to a restaurant and you write your name. Not even yourself can read your name on the form, and you know they give the number wrong, and it's a bit of a mess. So I'm sure we can do better.
Yeah, and we will at some point. And I know there are many different approaches, and there are projects that they will begin shortly, and we will be there. I mean,
cool,
excellent. I think this was a super productive discussion. I think we're on the hour almost. This went fast. Thank you guys very, very much for all this information. It's like super useful, and hopefully we can have you again sometime, like once this stuff progresses and like the country's response through your new software becomes even better. We could discuss it even more.
Sure.
And we capture it in the blog. So the guys, you know, wrote a blog, so it's in the Quarkus customer story, so people can, you know, read a little bit more there. And I know there's also a video about the backend AI algorithm that maybe we could share in some notes or something. Yes.
Sure. Okay.
Awesome. Well, and don't forget, folks, Quarkus 110 is coming out in a few days, so grab that once it comes, or you could try the CR1 right now.
All right. Well, looking forward to ending the lockdown and everything, so we can travel back. Some of us, yes.
That's right.
All right, take care. Huh?
All right, thank you for that.
Bye bye.
Thank you for that. Yes.
Fingers crossed. So thanks a lot. Have a good day, everybody.
Bye.
Bye-bye.